what we were seeing in the last class. So the next slide, the classification of liquid crystals. This is another very important classification. Watch very closely because you have to understand each and every point. The liquid crystals can be divided into two types. One is called smectic liquid crystals, and the other one is called nematic liquid crystals. Smectic means soap like, it will be like a soap water, whereas nematic means thread like. The soap like smectic liquid crystal will have a limited mobility. They do not move fast. Limited mobility. And also you can see layers like arrangement, which means that suppose if you take the smectic liquid crystal and flow it over a glass plate, you can see different planes gliding over another. One plane will flow and another plane will flow over that, and another plane will flow over that, different planes gliding over another. And also the motion is a non-Newtonian motion. You should understand the difference between the Newtonian motion and the non-Newtonian motion, which means that one layer will drag the another layer, so the momentum will be exchanged, and it is a non-Newtonian motion. And also the viscosity is not appreciable. It is not more viscous. And also on glass surface, you can see the formation of a terraces or strata. The crystal arrangement is still found in there, but only thing is the difference between the solid crystal and the liquid crystal of smectic type is the spacing is different. The distance between the two crystal layers in solid state and the distance in the liquid state will be different. So if you take the X-ray diffraction, you can see the X-ray diffraction only in one direction in the liquid state. But the internal structure is very complex. They have fan-like, they show fan-like structure in the polarized light. They are uniaxial and they are not affected by the magnetic field. So these are all the explanations for the smectic type of liquid crystals. And if you take the smectic type of liquid crystals, it is something like the diagram that is given here: a layer above another layer, a layer above another layer, layer above another layer, and they will flow in this fashion when they are poured on a glass plate. And the examples of our smectic: ethyl para azoxy benzoate, ethyl para azoxy cinnamate, N-octyl para azoxy cinnamate. These are all some of the examples of our smectic liquid crystals. And another type of liquid crystal is a nematic liquid crystal. Actually, they are thread-like and they show normal flow behavior. And their motion is a Newtonian motion, and they have appreciable viscosity, and the viscosity is lower than that of liquids. And the turbid, they show anisotropic behavior, but here the anisotropy is greater than that observed in the smectic type of liquid crystals. And they are also uniaxial, but they are affected by the magnetic field. So when the magnetic field is given, they form a clear liquid. When the magnetic field is off, they will become turbid. So this is how the nematic liquids are used in this liquid screen. See, you are using the calculator, no? In the calculator, the digits are appearing where the nematic liquid crystal becomes a turbid. So when you press a number, that line or the dots which fall on the number They are subjected to magnetic or electric field, and the other numbers will become clear liquid, and that particular number in which the magnetic field is off will become turbid. So this is how the numbers are appearing in the liquid crystal screen. Even you can take a liquid crystal screen of an old calculator or a digital watch, or the numbers shown over there. You can take that and you can break and you can see the liquid coming out. You can see that. I have done such experiments at home. I have taken old thrown out watches or thrown out calculators and broken the screen, and I separated the layers, and I have seen how the liquid crystals are kept inside and how they are working with the electricity and all that I have seen. You can also observe this. Some worn out cell phones, you can take the screen and break it and see what is inside actually. So these are all the various observations you can make. And the examples of our pneumatic liquid crystals are para-azoxyanisole, para-azoxyphenatol, para-methoxycinnamic acid, anisaldazine, anisaldazine, dibenzol benzidine. These are all the examples of our pneumatic type of liquid crystals. So in order to make you understand, I repeat what we have seen in this slide again, and then we stop the class. Look here, the liquid crystals can be divided into two types, namely smectic and pneumatic. Smectic means soap-like. They have limited mobility and they are found in layers, and different planes are gliding over another, and their motion is non-Newtonian motion. And the viscosity is not appreciable. On glass surfaces, they form terraces or strata, and the crystal arrangement is still found in the liquid state, but the spacing between layers are different in the case of liquids and solids, and the X-ray diffraction is found, but only in one direction. And this shows the complex internal structure, and it has a fan-like structure when it is seen with the polarized light. It is uniaxial crystal, but they are affected by the magnetic field. But if you take, yeah, the pneumatic structure has a thread-like structure, and it shows a normal flow behavior, and the motion is Newtonian, and the viscosity is appreciable, and the viscosity is lower than that of the liquid itself. Turbidity, it shows anisotropic, but the anisotropic behavior is greater than that of smectic liquid, and it is also uniaxial, but it is affected by the magnetic field. So when the magnetic field is applied, it shows a clear liquid, and the magnetic field is off, it is showing turbid nature. So these are all the differences between two different types of liquid crystals. I think now it is time. I think I can stop now. So okay, let us see in the fifth hour.